This chapter talks about metals bonding with other metals. So we talked about a metal and a nonmetal. That was ionic. We talked about a nonmetal and a nonmetal. That was covalent. If you talk about a metal and a metal, that's simply called metallic, right? It's a metallic bond. So here's how metals bond with other metals. Again, metals like to lose electrons. They like to become positively charged. But how would a positive attract to another positive? It wouldn't. That wouldn't work. So how do metals bond to other metals? The way they do this is the metal will simply give up its electrons that it doesn't want. Normally it would have to give them to something else, but the something else is another metal that doesn't want them either. So these electrons that they're giving up are just freely floating between all of these positive ions of the metals. And so since electrons are negative, then you have this sort of negative glue that holds all of these positive ions together. Right? We call this a sea of electrons. So there's a sea of electrons in a metal that holds the metal together. That also kind of gives us some clues as to why metals act the way they do. Why are metals good at conducting electricity? Well, look, it's got all these free-flowing electrons already. So it would be really easy to have electrons just kind of flow right through the metal. And that's what electricity is all about. Why are metals really good at being malleable? Why can they bend really easily? Well, look what's holding them together. You have this sort of free-flowing glue that's holding it all together. It'd be really easy to bend this without breaking it. So a metallic bond is the force of attraction between those free-flowing electrons and those positively charged metal ions. So metals do have an order, right? They line up. There has to be a positive ion and then some negative electrons, and then a positive ion and then a negative electron, and a positive ion, the negative electron. There has to be an order to this. So metals have a crystalline structure, just like ionic compounds have a crystalline structure. They have an order to them. And you can mix metals together. They would be forming alloys. Like, for instance, brass is an alloy, right? It's copper and zinc. Or you can mix carbon and iron together, and that's how you make steel, right? Those are alloys. So two different metals that are mixed together. In fact, you don't even have to be two different metals. It can just be a metal and some other element that is mixed together. And of course, they'd have to mix them when they were liquid, and then they let them cool down into solids.